Hello everybody. So here we have problem 6.5 and we have three states. The first state as energy, so I'm going to put E as S1, negative 0.05 electron volts. The second state is 0 and the third state is 0.05 electron volts. So the first thing we want to do is calculate Z. Well, Z is equal to the sum of E to the power of negative E of S divided by K T. Oh, and T is equals to 300 Kelvin. So now we can start solving it, and we can say that Z then is equals to E at the power of negative 0.05 divided by K, in this case, is equals to 8.6 times 10 to the power of negative 5 times 300 plus E at the power of negative 0 divided by KT. I'm not going to write this stuff because, of course, it's going to be 1. E at the power of negative 0.05 divided by 8.6 and 10 to the power of negative 5 times 300. So here we just plug in our calculator and we get E power of 0.05 divided by 8.6 times 10 to the power of negative 5 times 300. 6.95 plus 1 plus, and purchase the same E, instead a negative exponent. So it's 0.144. So in total, so we have 1 plus 6.95 plus 0.144 is equals to 8.094. This is our Z. So we calculated. Then B, we have to find the probability. The probability then is equals to 1 over Z times E to the power of negative of S divided by KT. So we can say probability of the first state of S1. That's why I called S1 or something like that. So 1 over, we said 8.094 times E to the power of, actually, we already know what that, the first one will be, is equals to 6.95. Then the second one will be 1 over 8.094 times 1. Then the third one will be 1 over 8.094 times 0.144. 0.144. So here we have for the first one we have about 0.86, the second one we have about 0.12, and then the third one we have 0.018. Write this better. So these are our three probabilities. Now we have to repeat the same with, instead of having we're just going to take our energy and add 0.05. So energy S1 will be equals to 0. Energy of S2 will be equals to 0.05 electron volts. Energy of S3 is equals to 0.1 electron volts. So what we said is that the 0 point for the measuring energy is arbitrary. So that means that we should get the same probabilities. Let's test it out. So we're going to have Z is equals to E the power of 0 divided by KT. I'm not going to solve this. I'm going to write all this up. So negative 0.05 divided by 8.6 and 10 to the power of negative 5 times 300 plus E to the power of negative 0.1 divided by 8.6 and 10 to the power of negative 5 times 300. So here we get 1 for the first one, and then what was it? I can just look it up back at what we did before. 0.144, 0.144 plus, and then we have E at the power of negative 0.1 divided by 8.6 and 10 to the power negative 5 times 300, 0.021. So in total, it's equals to 1.165. The probability for S1 will then be equals to what? Well, we have 1 over z, again remember, e to the power of negative e of S1 will be, and then kt. Now, we know that our z is equals to 1.165, and for the first one we have 1, so what is this? It's equals to 0.86. For our second one, S2, we get 1 over 1.165 times 0.144, which is equals to about 0.12, and then P as 3, 1 over 1.65 times 0.021, which is equals to 0.018. Now we can check it with the one we had before, and we can see that we were kept in order. 0.86, 0.86, 0.12, 0.12, 0.018, 0.018 are the same values. So this proves that our decision on what our zero is arbitrary, and we'll get the same probabilities in the end.